Hello everyone, and welcome to your first video lecture for Trig. We're looking at chapter 6 right now. You guys are going to be out till May the 1st, so most likely what's going to happen is you are going to have a test, and it will be posted in Canvas. I'll give you more information on that once I get started building the test itself. You see that you have 6 sections here for chapter 6. I'm not going to do the practice test. It is in Canvas with an answer key. You can get up with me if you have any questions on it as you work through it. Main thing I'm going to focus on, I'm going to try to do one video per grouped section. So 6.2 will be one video, 6.3 will be one video, 6.1 is one video, and 6.4 will be one video, for a total of 4 videos for the chapter. So right now we're going to work on 6.2. I will be posting your homework in Canvas. It will be book homework. If we need to adjust that, we can look into that. I just need you guys to send me a message and let me know. If you don't have your textbook, I should be able to take a picture and send you pictures of the textbook so that you can work the problems. All you'll have to do is just send pictures to me of your completed homework so I can put in a grade. But we only have Unit 4 and Unit 5, and then you're completely done with Trig, and then you'll have the final exam. And I don't have any information on the final exam right now. I'm waiting to hear from Miss Ashmore about the final. At the moment, it's most likely going to be a Canvas test, but I'll let you guys know more when I know more. So for now, we're going to focus on 6.2a and 6.2b, trigonometric equations 1 and trigonometric equations 1 again. Each of these kind of starts simple and then builds up, shows you some easy techniques, then some tricks before we get to 6.3, which is going to be trigonometric equations 2, which will be my second video. Okay, let's just scroll on down. Here's what we got. Notice that we're starting with 6.2 and not 6.1. 6.1, as you can see up here, covers inverse circular functions, which is going to be more helpful that you know how to solve the equations first before you start trying to solve with inverses. Okay, so solving trigonometric equations. Solution to trigonometric equations often involves angles 30, 60, 45 that you guys know are pi over 6, pi over 3, pi over 4. It could also be quadrantal angles, 0, 90, 180, 270, that you also know as 0, pi over 2, pi, 3 pi over 2, so degrees, or it could be in radians, or it could be decimal radians. Remember that we can also talk about radians in forms of decimals, ranging, if we're talking about 0 to 2 pi, we could also be talking about from 0 to 6.28 in radians. Just remember that pi is 3.14 radians. So make sure you keep that in mind. Some of your problems will switch in between degree, radian, or decimal. Okay, so looking at the first part, we're going to talk about solving for all angles. So sine of x is equal to 1/2 on the interval of 0 to 2 pi. What are the solutions? So what angle will let sine have a value of 1/2? And ask you to draw a picture. So we're going to look at this from a picture standpoint. So we're talking about this one. So sine 1/2, positive 1/2. Sine is positive in the first quadrant. Say this is theta or x. And if we're talking about sine, it's opposite over hypotenuse. Well, what angle that we know of, one of these, will let sine be 1/2? Well, we always know that our special triangles, if this was 30, that'd be 1, 2, root 3 for a 30, 60, 90 triangle. So we got to talk about 30 degrees here. Could be 30 degrees. You could also say this is pi over 6. So degree or radians. And then we have to see, we have another blank here. There is another spot that sine is 1/2, and that's in our second quadrant. with this angle here, this theta. How about 1 and 2? Well, what angle is this? This is 180 degrees to make a flat line. And we know this has to be some variation of 30 degrees to have 1 be directly across from it. So 180 subtract 30 degrees, we would get the angle 150 degrees. Which, if you want to talk about radians, that is 5 pi over 6. But what if we want to talk about this down here, sine of x being negative 1/2? Well, if we were using quadrant 1 and quadrant 2 for the first one, clearly in this one we're going to be talking about quadrant 3 and quadrant 4. This is where sine can be negative. This is negative 1 and then 2. This is negative 1 and 2. But I need to know theta. What angle? Well, we know it's variations of 30 degrees since both of these were variations of 30. And then again, this is 180 degrees, this straight line here. I'm at 180 and I go 30 more degrees going down. That gives me 210 degrees. And if we want to talk about that in radians, that's 7 pi over 6. Which, remember, if you don't remember radians, all you have to do is do degrees multiplied by pi over 180 and simplify these down. That would give me 7 pi over 6. We need to convert between. Alright, over here, we've got another variation of 30 degrees. This is 0 or 360 degrees. I'm not quite to make it to 360. I'm 30 degrees short, which would tell me that I'm at 330 degrees. And that would be in radians 11 pi over 6. Alright, so note, why do we limit the interval from 0 to 2 pi? In solving linear non-squared terms, trigonometric equations get the trig function by itself first, then consider the reference angle. We limit it down to 0 to 2 pi because remember, when we're talking about the period of a trig function, sine, cosine, sine and cosine, secant, cosecant, they have a period of 2 pi, which means after 2 pi they start replicating. For tangent and cotangent, we're talking about 0 to pi, and then they start replicating. Alright, so now we're going to be getting down here. We're going to be actually solving these equations. The main thing that we're trying to get you to understand up here is that we're not looking for just one angle. There could be multiple angles that give me the same answer. So down here you need to make sure you're trying to find all the angles that fit within this specific limitation, this range. Okay, so starting with number 1, is we have 4 sine of x plus 2 equals 0. We're going to solve it just like every other equation, get sine by itself, and then try to figure out the angle. So if I want to get this by itself, I'm going to subtract 2. So now I have 4 sine of x is equal to negative 2. And then I divide by 4. So I get that sine of x is equal to negative 1/2. From there, we try to decide what is the angle that makes sine be negative 1/2. And in this case, we're going to talk about it in degrees. So what angle measure in degrees will give sine a value of negative 1/2? We already did that up here. We do know that it's going to end up being 210 degrees, and we know it's 330 degrees. Okay, number 2, same thing. We're solving this. We subtract 2. We get 4 cosine of x is equal to negative 2. Divide by 4. So I get that cosine of x has to be equal to negative 1/2. Well, now this one's a little different. Now I've got to think about where is cosine equal to negative 1/2. So let me draw a picture. Well, cosine is not negative in the first quadrant. So it can't be first quadrant. We're not talking about here. Cosine could be negative in the second quadrant. Where this is our negative 1 and this is our number 2. Well, what angle would allow this picture to happen? Here's our root 3 right there. Always across from square root of 3 is 60 degrees. Well, if this is 60 degrees, but we're talking about second quadrant, we've got 180, subtract out the 60, so I know that the first one has to be 120 degrees. Well, where else is cosine negative? Third quadrant. Where this is still our negative 1, here's our 2, here's our negative root 3, here's theta. Still some variation of 60 degrees. And so I've got 180, add 60 degrees to it. It's 240 degrees. So these are the only two angles that will allow cosine to give me a value of negative 1/2. Scrolling down, 4 cosine x plus 4 is equal to 0, but this time, instead of writing answers in degrees, we're going to be talking about radians, in terms of pi. So working on this one, I'm going to subtract the 4. So 4 cosine of x is equal to negative 4. Divide by 4. So cosine of x has to be negative 1. I would put a star by this one. This one's special. This one's not our normal 30, 60, 45. This was one of our quadrantal angles. So in this case, I need to know, remember that cosine is x over r. R is always 1. That means that x has to be a value of negative 1 for it to come out to be negative. Where is the only quadrantal angle that gives me a negative 1 value for x? And that is right here at the point negative 1, 0. There's my x, there's my y, and r is always 1. So this angle, 180 degrees, or since we're talking about in terms of pi, x has to be pi. At this point in the video, I would pause, try to work out this question here. 3 tangent x minus 2 is equal to 1 in terms of radians. I would try to work this one out, see if you can get it. So I'd pause now. Okay, hopefully you paused the video. If you didn't, that's okay. We're going to work it out now and see what the answer is. So plus 2, get 3 tangent of x is equal to 3, divide by 3. So tangent of x is equal to the number 1. So I got to start thinking now, where is tangent equal to 1? Where can tangent be positive is the first question. Tangent is positive in first quadrant. Tangent is also positive in third quadrant. this case, the only way tangent can be 1 is if this is some variation of 45 degrees. 1 root 2. That means down here, theta, -1 root 2. So first angle, we know it's 45 degrees, but we got to do it in radians. So that means x has got to be equal to pi over 4 for this one. So this is pi over 4. Now down here, we already know that this is pi, or 180 degrees. I've got to add pi over 4 to pi, common denominators. I'll do it over here. So pi plus pi over 4. Well, that means this is 4 pi over 4 plus pi over 4. That way they've got common denominators. So it's 5 pi over 4. And these would be the two angles where tangent can be 1. Hopefully you got these two answers, or at least one of them, so that way that we know we're on the right track. You'll get better at these the more that you practice them. Alright, looking down here, solve the following quadratic equations. So we can either do one of two things. You can get the trig function by itself and then square root both sides, or set the equation equal to 0 and then factor. Either method will work. Now you'll see on some of these I perform one method and others I perform a different method. It just depends on the way the setup is at the initial start of the problem. In this one's case, I would go ahead and do the first method of get trig by itself and square root, because I only have a trig function and a number. That's easy to solve. Number 6, I would probably start with the same thing. I would try to get the trig function by itself and square root. Number 7, yet again, trig function by itself, square root. Number 8, I'd factor. I've got two trig functions. I want to try to factor one of them out. Number 9, I would attempt to factor this one as well, because there's multiple trig functions. And 10, I would factor. And then on 11, what you can't see is already factored, and 12 is already factored. So I'm going to say, go ahead and write these down so you can see them. Square root. Actually, I'm just going to do the symbol. Square root here. I'm going to square root this one. I'm going to square root this one. I'm going to put a little f here. I'm going to factor. This one I'm going to factor. And this one I'm going to factor. Okay. So starting with the first one, I'm going to add 1. So tangent squared of x is equal to 1. And then I square root both sides. So tangent of x has got to equal plus minus 1. Since I took a square root of both sides, I do have plus minus. And we're talking about degrees. So, we've already talked about where tangent can be 1. We talked about this in the last problem. We already know that is pi over 4 and 5 pi over 4. So I'm not going to waste time going through that again, but let's talk about tangent when it's negative 1. Where can tangent be negative? Well, second quadrant, where this is 1 and negative 1. And fourth quadrant, where this is 1 and negative 1. And here's our thetas. Okay, so here, this first triangle, if this is 180 degrees, but I'm not quite, my angle hasn't quite made it all the way down, I'm missing this piece, this pi over 4 piece, that means that this angle, pi minus pi over 4, would give me 3 pi over 4. And then this piece over here, this is, remember, 2 pi, but I haven't quite made it there yet, so I got to subtract out a pi over 4 here, That's going to give me 7 pi over 4. So my total answer, x can be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So these are the values that would work for this question. All right, number 6, I'm going to go through it quickly. Oh, I forgot to do those in degrees. I do apologize. That was 45 degrees, 135 degrees, and then we're going to be talking about, we said 5 pi over 4. This is going to be 225 degrees, and then 315 degrees. All right, here, number 6, we're going to subtract 1, so tangent square root of x has to equal -1. Take the square root. Well, here's the problem right there. Tangent of x has to equal plus minus I. At this point, you do not know how to work with trig functions and imaginaries, so therefore this is a not possible. Alright, you should work out number 7. I'm going to give it a few seconds. Hopefully you paused the video and worked out number 7. So we're looking at 3 cotangent squared x minus 1 is 0, interval 0 to 2 pi. So what we're really talking about is cotangent of x. So I add 1, divide by 3, that's 1/3, and then take the square root. So I have 1 over, so plus minus 1 over square root 3. So I need to know all of these angles. So let's start up here. Here's theta. And cotangent is adjacent over opposite. So that means that opposite, or adjacent to that, is going to be my number 1, and then opposite is my root 3. Well, opposite root 3 is always 60 degrees, and 60 degrees in radians is pi over 3. So there's the first one. Looking here, this is going to be one of our negative ones because we're talking about theta. Theta needs to be, okay, so adjacent needs to be root 3, no, 1. Well, in this case, we have -1. Is our adjacent, opposite is root 3. Well, if this is 180 degrees and I take away pi over 3 or 60 degrees, that's going to leave me with 2 pi over 3. Down here, here's our theta. We still have -1 here. Over here is negative root 3, so we're talking about one of the positive answers. Well, I've got 180, and I have to add square root 3. I mean, not square root 3, I do apologize. I've got to add pi over 3. That means I'm talking about 4 pi's over 3. And just to make sure we see that as pi plus pi over 3. Make them common denominators, so 3 pi over 3 plus pi over 3 is 4 pi's over 3. And our last angle here, here's our theta. 1 is still here. Now we have negative root 3. So we're talking about the last negative answer. Still some variation of 60 degrees. We have 360 or 2 pi. Take away a pi over 3 or take away 60 degrees. That leaves me with 5 pi over 3. And there is all of my answers. number 8. Here's with number 8, we're going to factor. These both have cosine in common. So I'm going to factor out a cosine. And here, this is a difference of two squares. So I can factor that again. And now that I've done that, I can set each one equal to 0. So cosine of x has to be 0. Cosine minus 1 has to be 0, which means cosine has to equal the number 1. And cosine plus 1 has to be 0, which means cosine has to equal negative 1. Well, cosine is 0 in two places, two quadrantal angles. We're talking about when x's are 0, so that's here and here. So that means we're talking about pi over 2, which is the top, 90 degrees. We're talking about 270, which is 3 pi over 2 down here. Well, we talked about cosine being, we talked about cosine being negative 1. Let's go ahead and do that. X has to be pi. So there's pi over 2. Here's 3 pi over 2. And when you talk about where cosine is 1, well, that's right here. Now, to make sure you do not make the mistake of what to put, this bracket means include 0, but this parenthesis says do not include 2 pi, which means the answer for this middle section is not 2 pi. It's not included. We have to include 0, which means out of the two choices, 0 or 2 pi, 2 pi is not actually a choice because of this limitation, the way they wrote it. Therefore, 0 is the only answer I can put. So, writing out my answers, I'm going to have 0, pi over 2, pi, and 3 pi over 2. Alright, I'm going to go ahead and just show you the factors here, because it's already 27 minutes into this video, so I'm just going to go ahead and show you the factors. I think you can work them out from there. Okay, so tangent x plus 1 squared, we're really talking about when is tangent of x equal to negative 1. That's what we're trying to find. You tell me the angles. Here, factors for this one, I've got 2 cosine of x plus 1 and cosine of x minus 1, which means I'm wanting to know really when is cosine equal to negative 1/2 and when is cosine equal to 1. Well, we already know this one's 0. The other one, I'll go ahead and tell you these is 120 and 240. And this one over here is 135 and 315. Alright, scrolling down, these are already solved for, so that means I need to know when cosine is 4, and I also need to know when sine is negative 1. Well, right here, cosine being 4 is undefined. Cosine is stuck. Just as a remember, there's 1. Down here is negative 1. Cosine comes down, hits there, and comes back up. Cosine cannot be the number 4. Secant. Now, if I want to talk about secant, secant can be the number 4 several times. Cosine cannot. Sine, when is sine negative 1? We know this already. It's down here. It's quadrantal angle. It's 270 degrees. Alright, over here, we're looking at when is tangent equal to 1 and when is sine equal to negative 1/2. Sine being equal to negative 1/2 is 210 and 330. Tangent being equal to 1 we know is 45 degrees, and also in the third quadrant 225 degrees. Okay, so looking at section 6.2b, tricks for solving. If the equation involves more than one trig, try to set the equation equal to 0 and then factor, if we can. Substitute for one trig function, or square both sides, then substitute trig functions. Squaring both sides gives extraneous solutions, so you'd have to check your answers if you do the squaring of both sides technique. Alright, so looking at the first one. Here, sine x tangent x equals sine x. I want to get this sine of x. I'm going to follow first trick, get it equal to 0, so I'm going to move sine over. So I've got sine of x, tangent of x, minus sine of x is equal to 0. Once I have done this, it says, and then factor. Well, now I have two expressions that have sine in them, so I can factor sine out. It leaves me a tangent and a negative 1. Now that I've factored, I can set each equal to 0. I'm going to go ahead and solve this real quick. Tan minus 1 is 0, which means we're looking for when tan is 1. When is sine equal to 0? And we're talking about it in terms of degrees here. So always look to see what they want the answer in. Well, sine is equal to 0 in two places. Basically, whenever y is 0. Well, that's two places. We have 0, and we also have pi. Because this is 1, 0, thus we're looking right there. And here it's negative 1, 0, and we're looking right here because sine is y over r. So if y is 0, then sine is 0. Well, tangent is equal to 1. We've already done this several times. Oop, I don't know why I put pi right there. We're talking about degrees, 180. So tangent equal to 1, we've done this several times. We know it's 45 degrees and 225 degrees. Oh, yes. I almost put 135 without that other part of that symbol being there. Over here, same thing as before. I'm going to solve, move this over. So I have sine squared cosine minus cosine. Factor out cosine. Set each equal to 0. And this I'm really talking about when sine, since it's sine squared minus 1, that really means that I'm looking at when is sine positive and negative 1. Because remember, if I have sine squared equals 1 and I square root both sides, I get that sine has to equal positive negative 1. And yet again, we've talked about this before, and we've talked about cosine being 0. Cosine is 0 in two places, pi over 2 and 3 pi over 2. Sine being equal to 1 is quadrantal angles as well. It's pi over 2, which is up here, and 3 pi over 2 down there. Which means our answer is just, we don't have to worry about having this twice, we only need one set. Pi over 2 and 3 pi over 2. We don't have to double up. Okay, down here, we're using trick number 2. Substitute in a trig function if we can. I want to get everything in terms of one trig function so then I can solve. So what I'm going to do is I'm going to replace cosine squared with 1 minus sine squared, and then I'm going to work on getting these down to equal 0. Or some other number, just depends. So here, I'm going to move sine squared over. Now I've got 2 sine squared. And now I'm going to subtract 1. and divide by 2. I'm going to continue it over here. So now I have sine squared x is equal to 0. I square root both sides. So I'm looking for when sine of x is equal to 0. We don't have to put plus minus because plus minus 0 is still 0. And we've done this before. We're talking about the angles at 0 and 180 degrees, since we're talking about degrees over here. Okay. Yet again, we can get these in terms of one trig. Originally, when I did this problem, I didn't do that. I actually just went ahead and factored it and played a weird game of when are sine and cosine equal to each other and when is sine equal to negative cosine. But let's not do that. Let's do it the much more simple route, and let's say the same thing we did before. Cosine is 1 minus sine. Okay, now that I've done this, I distribute my negative. Combine my functions. And now I move the 1 over. Divide by 2. And take the square root. Continue it up here. I'm looking for when sine of x is equal to plus minus 1 over root 2, or another way to say that is the square root of 2 over 2. Since I'm talking about positive and negative, I know I'm talking about all 4 quadrants. So I'm looking for 4 angles. And if we're talking about square root of 2 over 2, that should give you the indication that we're talking about 45-degree angles. And since we're talking about radians, we're talking about pi's over 4. So looking at this from a picture format, I know that I need 1 over square root of 2. This is 45 degrees, or pi over 4. So that's the first one. Over here, I've got 1, there's my root 2. Here's theta. This one over here is 3 pi over 4. Because we're talking about 180, subtract a pi over 4. Down here on the bottom, negative 1 and root 2. This is 5 pi over 4. And last one over here, theta, negative 1 and root 2. This last one is 2 pi, subtract a pi over 4. That leaves me with 7 pi over 4. So each one of these is my angles. All right, number 5. Number 5 is one of those squaring both sides problems. Because I have square root of 3, that's what the indicator is for me to say, oh, I'm going to have to square both sides. The other indicator I'm looking at in this problem is I can't substitute anything for tangent other than sine over cosine. Over here, same thing. It'd be 1 over cosine. That doesn't really help me in this instance. And if I multiplied everything by cosine, then I'd have another trig function. I have 3 trig functions, and that just is a giant mess. So instead, I'm going to use the trick. I'm going to square both sides. So tan of x plus root 3, square it. And I've got secant of x over here. I'm going to square it. So when I square this one, I get tangent squared. And just so we remember that we don't make this mistake, I'm going to write it up here. Tangent plus root 3. Tangent plus root 3. And this is what it means to square. I distribute to both. So tangent times tangent is tangent squared. Tangent times root 3 is root 3 tangent. And then root 3 times tangent is another root 3 tangent, which means I have 2 root 3 tangent. And lastly, I have root 3 times root 3, which is 3. And that's going to be equal to secant squared. Now, something I know about secant. Secant can be turned into tangent. Remember, we always said that we have sine square, cosine square is 1. If I divide everything by cosine, I get tangent square plus 1 is equal to secant square. So I'm going to substitute secant squared with the tangent squared plus 1. And I'm going to show you a nifty little trick. If you have the same term on both sides, they cancel out. So if I subtract here, it's going to subtract from there and they're going to cancel. I'm going to subtract 3. So 2 root 3 tangent is equal to negative 2. Divide by 2 root 3. So I'm looking for when tangent of x is equal to negative 1 over root 3. Well, so I need to think about when tangent is negative, not first quadrant. It's allowed to be negative in the second quadrant. Opposite has to be 1. Adjacent has to be root 3. And we're talking about this in terms of degrees. The other place, and we'll just draw 2 separate pictures. Tangent can be negative in the fourth quadrant. Here's theta, negative 1, and here's root 3. So over here, opposite of 1 is always a 30-degree angle. Therefore, if this is 180 and I subtract away 30, that means that it's got to be 150 degrees. Here, if this is 360, yet again this is a 30-degree angle, and I take away 30, that means this has to be a 330-degree angle. Now, something gets said at the top of the page that I can't scroll up to right now is that squaring them can make extraneous solutions, which means all you have to do is plug these into the original function and determine which one is real, which one is not, or if they're both real. In this case, to save us some time, this 150 degrees is what we would call extraneous. The 330, however, is a valid solution. Okay, almost done. Now we got part B, solving graphically. We've done this before in class, so I'm not going to spend a huge amount of time on it. Okay, remember that to solve these graphically, we put this, I'll go ahead and show you here, we put this in y1, this is y2, and then when we do that, we determine what they are, where they intersect. Okay, I'm going to go ahead and tell you what I got for these so you'll have it. This is 46.5 degrees. This one is 133.4 degrees. Number 2, I got 71.5 degrees, 108.4 degrees, 251.6 degrees, 288.4 degrees. Number 3 is switched over to radians. I got 0.54 radians and 3.68 radians. Just make sure you stay within the normal bounds. Remember, this 2 pi means I can only go up to 6.28. Number 4, I got 1.878 radians. And this one, 4.405 radians. And finally, number 5, 0.842 radians and 3.199 radians. So now what I'm going to do is I'm going to show you real quick how to do this with Desmos so that way you can see it. Alright, so here y1 for number 1 is sine of x, and y2 I want it to be equal to, y has to be equal to 0.7263. Alright. So what I did on this is I looked for everywhere there was an intersection. Now, right after, see, there's my 2 pi, so I know it can't be anything after this mark here. These 2 marks, 0.813 and 2.329, those are in radians. So I took those and multiplied them by pi, take it back, I multiplied them by 180, divided them by pi, and that's how I got your angle measures. So this is exactly what you want to do. Type trig function or the left side of the equation in the first one, type the right side in the second one, find where they intersect from 0 to 2 pi. Okay, just want to show you again. So let's look at like number 2 is secant, so secant squared. Okay, so there's my secant squared, and it says I have to be equal to 10. So let me scroll up right here from 0 to 2 pi. And so in degrees, so I've got 1 right here, 1.249, 1.893, 4.391, and 5.034. Remember that 2 pi means I can't go anything past 6.28, so this is too far. So 1, 2, 3, 4, and then convert them into degrees. Alright, last one I want to show you, because this one's a little weird, is I have cotangent of x plus 2. It's the left side, this is number 5, and I have 7x minus 3. So there's my first one that I found was 0.482. And then I zoom way up here, and it's right here with 3.199. And if I keep zooming up, so there's another point that it connects, but 6.3, which is beyond the 6.28 threshold. Alright guys, with that, that's the end of 6.2. We'll talk about 6.3 in the next video.